Shut the door.
All right, so I'm going to hit some high points on this. I don't want to read the whole thing to you, but this whole section we're doing t-distributions. We're not doing standard. The only exception to that would be if you actually knew the standard deviation, okay, which almost never happens. If you knew the standard deviation, you almost have to know the mean as well. The fact is, you have to know the mean in order to calculate the standard deviation. So I suppose you could be told it, but so a couple things to notice. S stands for the standard deviation of the sample. I find that sometimes students don't know that, whereas the standard deviation of the population is sigma. For the most part, the Greek letters are for the whole population, and the regular letters are for our sample. Okay? How is a t-distribution different than a normal distribution? It's a lot the same, except there's more area in the tails than there is in a normal. Until you get to have a lot in your sample. When you have a really large sample, let's say you even had just 50 in your sample, you would be hard-pressed to tell that it was not a normal distribution. In fact, as if you did it with a normal distribution, your answer probably to several decimal places would be exactly the same. Okay? So as the number of degrees of freedom increase, a t-distribution looks more like a normal distribution. So here's the whole deal about how to make confidence intervals for a population mean. I took most of the material for this out of the College Board's material on this. So in some cases, the wording differs slightly, but this is the way College Board says it. So it talks about the appropriate test is a one sample t interval for a mean. That also includes matched pairs where you're finding the differences. Your calculator just calls this a t interval. What are the conditions? Basically, the conditions are always, in general, the same. Two things. One is you have to have independence, and two, that your sampling distribution is approximately normal. How do you ensure that? Well, for this one, you've got to either have a random sample or a randomized experiment, or, and this came up a lot in your book, and I don't know how much this comes up on the AP exam, you have to have a sample that you believe would be representative of the population.
They do say that.
Yeah,
there's a lot of questions about it.
And I couldn't find that it said that anywhere in the information from College Board. So that may be a difference. If you're sampling without replacement, you have to have the less than 10% rule. If it's an experiment, are you sampling? No. So there is no 10% rule. I did read some stuff this weekend where apparently that's a new emphasis for statistics, for scoring. So if you put that this is less than 10% of the population and it's an experiment, you will lose points for that. Because it shows that you don't really know what you're doing. You're just, I remember you have something about this, and I'm just, picking and choosing. Okay. So we need the sampling distribution of the sample mean, which is x bar, to be approximately normal. How do we check that? Well, you can use either a histogram or a box plot, either one, to show that the observed distribution is free from outliers or strong skew, or you have to have a big sample size, 30 or more. Okay, those are your two choices on those. If it's more than 30, you don't even have to worry about the histogram, but you should mention this is a large enough sample that the sampling distribution is approximately normal. All right, I give the general formula. This general formula is on your sheet. That's exactly the way it is on the sheet. That the confidence interval is the statistic plus or minus the critical value times the standard error of the statistic. In this case, the statistic is x bar, the mean of the sample. The critical value, t star, which is determined by both the number of degrees of freedom, which remember for this is one less than the sample size, and the confidence level, and that can be found then in the chart or using your calculator for inverse t under the distribution menu. And the standard error, this is given. Standard error, the statistic, that's given on your formula chart. It's S over the square root of n. One thing to note on that then, if I want to cut my margin of error in half, oh, and remember that, and I sometimes forget, this whole thing, critical value times standard error of the statistic, that's margin of error. That plus or minus is the margin of error. So if you want to cut in half your margin of error, and you want to do that by changing your population, you got to make your population 4 times bigger, because the square root of 4 is 2. If you want to cut your margin of error by a factor of 10, you have to have a sample that is 100 times bigger than the one you currently have. And that's likely to be problematic. Either because if it's something where you're sampling, it's hard to sample that many people, or you could be getting to the place where you're over 10% of your population. Either way, it gets tough. All right, here's something that I want to highlight. I haven't made enough of it. I talked to Mr. Hedstrom yesterday, and I did some looking around. Basically, on our test this week and on the AP exam, you're welcome to use your calculator to do something on the test, but you must show all of the values substituted into the equation. So on this, you're going to say the critical value equals, you need to put a number in for the statistic, plus or minus, put a number in for the critical value, times the standard error of the statistic. Those 3 values must be filled in, and then you can give me the confidence interval. Okay? By doing that, you don't have to name the test specifically, although that's a good idea. You don't have to name the test or the procedure specifically because you have shown that you know the right formula to use. Okay? All right. So with confidence intervals, I think everyone has finally gotten to the place where they're pretty good at this. We are C%, whatever that C is, confident that the confidence interval captures the population mean. When you're interpreting, you have to include 2 things, and this is straight from the College Board, a reference to the sample taken and details about the population. So you have to talk about both the sample and the overall population that it's drawn from. The meaning of C% confidence is that in repeated random sampling of the same sample size, approximately C% of the confidence intervals created will capture the true mean. That's what it means to be 95% confident, that 95% of the confidence intervals that you would create from a population of that size, from a sample of that size from this population, about 95% of them would capture the true mean. All right, the test for mean, it's called a one-sample t-test for a mean. Your calculator just calls it a t-test. It's the same conditions. The null hypothesis is that the mean of the population, mu, so again, when it's a Greek letter, you're talking about the population. The mean of the population is equal to mu sub 0, which is some hypothesized mean. And depending on the situation, your alternative hypothesis could be that mu is less than the hypothesized, greater than the hypothesized, or just not equal to the hypothesized. Okay, a reminder that when you're doing the mean difference of matched pairs, mu sub d it's important to define the order of subtraction. You got to say which order you subtracted them in, because either is fine, but you just have to state that. All right. Then here's the general formula for any significant tests, a significance test. Again, that's on your blue sheet. That's not something that you have to memorize. In this case, the standardized test statistic is t with n-1 degrees of freedom. The statistic and the standard error are the same as they were for the confidence interval, and the parameter is the hypothesized mean, whatever that was. So this is what they think it is. It's 0 in the case of the mean difference with matched pairs, right? Because you're like, do we believe there really is a difference? Then when you use that to find P, you can use the TCDF on your calculator under the distribution menu. And that's the probability of having a sample that has this or a more extreme statistic, assuming that the null hypothesis is true. This is why when P is very low, we reject the null. And we're like, that's too improbable for the null to be true. So we reject the null. And then again, after you either reject the null or you fail to reject the null, in context, you talk about the alternative hypothesis. Your conclusion is always about the alternative. Okay? And again, just a general reminder, show your work. Show what it is that you're doing on that. Now, if you've got the difference of two means, where you've got two samples, it's just a two-sample t-interval. All right? The conditions are basically the same, except that it has to be two independent random samples or randomized experiments. So these two samples need to be independent of one another. Again, both samples have to be less than 10% of the population from which they are drawn. And both distributions, and again, so if you're actually doing this, you either have to show two histograms or two box plots, or each sample size has to be bigger than 30. One or the other. Your book doesn't really talk much about the sample sizes being larger than 30. I get the impression that they don't like that very much. But it's I mean, this is word for word out of the College Board stuff. So and basically the other stuff is the same, except your statistic is the difference between the two sample means. The critical value, this is the one where you can't find T star except by using your calculator. It won't, I mean, you can't. Those are the ones where the degrees of freedom are some weird number, and I don't understand that. I talked to Mr. Hedstrom about, that was one of the things I asked him about yesterday when I was talking to him, and he's like, yeah, that's an advanced statistic thing, figuring out why the degrees of freedom is some decimal number. And I'm like, okay, I don't want to do advanced statistics, so I'm just going to nod my head and smile. And the standard error of the statistic, again, that's given on the blue sheet, so you don't have to have that memorized. And then, the test for the difference of two population means, it's very similar. The conditions are the same. The null hypothesis is that the difference is 0 or that they are equal to each other. Either way you want to write that is fine. And then depending on the situation, your alternative is that the difference is negative, the difference is positive, or the difference is just non-zero. And again, the parameter for this one is going to be that it's 0, because you're assuming that those two are equal to one another. So there is no difference between the two. All right. Does that help kind of put it together for you? Good, because I spent about 2 hours doing this. I was like, Well, because I was trying to think about everything and trying to distill and get rid of all the stuff that we didn't need. So, anyway, all right. So you can go ahead and start working on your assignment.